Let's continue with polarity. The learning outcomes, you should be able to explain the bond dipole and dipole moment and deduce the polarity of molecule based on the shape and resultant bond dipole. You already know covalent bond is sharing of electron between two atoms or more. But do you know that there are two types of sharing? So let's have a look at the first one. If there is equal sharing of electron, we call it as non-polar covalent bond. So what are the examples? H2. So H2, H you have a partially positive and another hydrogen atom also partially positive. So the sharing of electron is equal between these two atoms. For example, Cl2. Okay, so this one, Cl, you know it is partially negative and partially negative. So the distribution of electron are equal for non-polar covalent bond. Okay, you can see here means the atoms that share the electron will have same or similar electronegativity as I showed before. So next, for covalent bond with unequal sharing of electron, we will call them as polar covalent bond. Means the atom, okay, so here it's supposed to be the atom will have different electronegativity. So, electronegativity, we will relate back to chapter 3, periodic table. You already know the most electronegative element is fluorine. The electronegativity always increase towards fluorine in the periodic table as shown in this figure. Another way to remember electronegativity is FON, F-O-N. Okay, so I always write this in this order. So the most electronegative atom is fluorine. Okay, so approaching fluorine means fluorine is the most electronegative, followed by oxygen, and then the least electronegative atom among these three is nitrogen. Okay, so let's go back to the unequal sharing of electron, polar covalent bond. So let's say you have this example, hydrogen fluoride, HF. So you can see for hydrogen, the atom is partially positive, and fluorine according to this method of remembering the order of electronegativity, I always write C north. So fluorine is the most electronegative atom. So for fluorine, it is partially negative and hydrogen partially positive. So you can see, imagine this cloud is the distribution of electron. The distribution of electron is more on the side of here for fluorine around here because it is partially negative. It will attract the electron more. As a result, the electron distribution is asymmetric, or in a simple word, it is not symmetry. Or we can call it as polar, means there are polarity here. This will cause the atom will have slight negative charge compared to the other atom, which will have a slight positive charge, and we will indicate this with partially positive or partially negative. A polar covalent bond is bond between atoms with different electronegativity, so you already know this concept. Okay, so you can see this example between HBr and OH. Okay, so HBr is a polar molecule. You can see for hydrogen it is partially positive, and so for bromine here partially negative. So you can see the distribution of electron is unequal or not symmetric. So how can we determine the polarity? We can determine the polarity by the value of dipole moment. So dipole moment, how can we get the dipole moment? Is the product of Q, which is the charge in coulomb, times with R. R is the distance that separates the center of positive and negative charge. But for your syllabus, you don't need to know the value and the calculation. You just need to know if dipole moment is high, means the molecule will have higher polarity. So you just need to remember these two important points here. So the first one is if mu or dipole moment is not equal to 0, means the molecule is a polar molecule. But if dipole moment equal to 0, the molecule is said to be non-polar molecule. Let's have a look at this example of hydrogen fluoride. So if you have hydrogen fluoride, so this is the representation of the electron density. So for this side, you have partially positive for hydrogen atom, and this side will be rich in the electron, so we label this as partially negative. So means the electron will tend to be at this region due to the electronegativity that we already learned. Fluorine is the most electronegative atom. So how can we show the direction of this polarity? So we can use this symbol. So this sign means from partially positive, and the head of the arrow is, this is partially positive and this is partially negative. So for your hydrogen fluoride, you can represent with this arrow to show the cross end of the arrow is to show the positive, partially positive, and the arrowhead here is to show the negative end or partially negative side of your molecule. Okay, just now we looked at example if you have two atoms, but what if the molecule has more than two atoms? So this one we need to determine the shape of the molecule, and then from there we will determine. So first thing first, you need to determine the shape of the molecule, and then next you need to determine the resultant dipole of the molecule. Okay, so this is the case if you have more than two atoms. So the overall dipole moment is the sum of its bond dipole. So you can see here the molecule that I have here is CH3Cl. So I will show you how can we determine the resultant dipole, and we can deduce whether this molecule is polar or non-polar molecule. So the factors that affect polarity, you need to remember, is the shape and resultant dipole moment, mu. Okay, so first let's have a look at the resultant dipole moment for molecule HCl. So if you have this molecule, draw out the correct Lewis structure, and then if it is two atoms, you can straight away determine the polarity. Okay, so for this example, to show the dipole moment, just draw an arrow. Okay, means it's heading towards the negative side of your atom, partially negative. And then the positive, partially positive side, we do a cross here. Okay, so this is to show the dipole moment. For the value mu, this will be not equal to 0 because we cannot cancel it off with anything. Therefore, we can say that this molecule is a polar molecule. Next, let's have a look at the second example, CO2. First thing first, you need to follow all the steps. Let's say, for example, the question, normally they will give you, determine the polarity of CO2. And then from here, you need to come out with the correct Lewis structure, and then with the correct molecular shape, and then you will come to this structure. And don't forget to write the correct Lewis structure and determine the partially positive. I notate here for carbon it is partially positive. For oxygen it is partially negative. So for both oxygen, by referring to the electronegativity, that is why I will always write C north arrow towards more negative. Okay, so for here, from here, you can know that carbon is the more positive. So oxygen, it is more electronegative. Therefore, for the dipole moment, you can represent it this way. And there will be two dipole moment, two arrow. Okay, so one pointing to the left and another one is pointing to the right. Okay, so you can see the dipole moment. So for this case, your mu or dipole moment will be equal to 0. Why equal to 0? So to make you understand, I will just put a value. Ini let's say -2, and then tengah ni let's say 0 lah. So the arrow pointing to the right, I give a value here +2 because the strength of the attraction is equal. Okay, so if you have one arrow pointing to the left and one arrow pointing to the right, means the dipole moment or the resultant dipole moment, the sum of it can cancel off. So you will get mu equal to 0. So you just cancel it off here. This dipole moment can cancel off with another. Therefore, you can deduce that this is a non-polar molecule. Okay, so let's try this practice. Okay, what if, draw the resultant dipole moment for each. For A, what if you have one dipole moment pointing to the left and one pointing to the right? So here, okay, kita dah buat practice ni tadi. Mu is equal to 0 because you can cancel it off. If mu equals to 0, therefore this molecule is said to be a non-polar molecule. So if you only have one dipole moment and it cannot cancel with anything, therefore mu kamu tu ada value lah. It is not equal to 0. Therefore, the molecule is a polar molecule. Okay, the last one. What if you have one resultant, one dipole moment pointing upwards and one pointing the other way? So the resultant or the sum, you will get it in this direction. Okay, so can it be cancelled? No. Therefore, your mu here, dipole moment, will not be equal to 0. This is a polar molecule. Let's have a look at non-polar molecule means dipole moment equal to 0. So the first case does not have, means the molecule does not have polar bond. Okay, the two atoms will have the same electronegativity. So for example, H2, fluorine, F2, and so on, with the same electronegativity. Next, the shape is symmetrical and the terminal atom must be the same. So, shape yang symmetry normally it involve the 5 basic shape. So, apa 5 basic shape ni? Linear, trigonal, planar, tetrahedral, lagi 1, 2, 3, 4. Yang keempat adalah trigonal, bipyramidal, and then the last one is octahedral. Okay, so syarat yang kedua adalah the terminal atom mesti sama. Barulah dia akan jadi non-polar molecule. Means the bond dipole can cancel each other because the shape is symmetry. So let's have a look at few example. Okay, so kita tengok contoh BCl3. Okay, so first thing first, you need to be able to write the correct Lewis structure and determine the shape. So BCl3, I will just draw the correct shape BCl3. Okay, so B is incomplete octet. So this is your structure and the shape is trigonal planar. Okay, so for the electronegativity, boron will be partially positive, partially negative for all the chlorine atom. Okay, so for the dipole moment, you can show it towards Cl. Okay, from boron towards Cl, boron towards Cl. Okay, so you can see that the shape is symmetry. Imagine the shape in 3D. So all the bond dipole will cancel each other. So another way to see this is, by, okay, I always divide into two parts. So Miss akan pilih di tengah ni, kita bahagi. Okay, so the first part ataupun bahagian atas, the dipole moment is pointing upward. Okay, so draw the dipole moment. And for the bottom part here, di bahagian bawah, satu bond dipole pointing ke arah bawah, and the other is pointing ke arah bawah juga. So the sum of these two ataupun resultant akan dapat this dipole moment resultant dipole pointing towards down bahagian, kalau in 3D it's not bahagian bawah lah, it's the opposite side. Okay, imagine this in planar. Okay, so these two dipole moment can cancel each other. Therefore, your dipole moment will be equal to 0 since they can cancel each other. Hence, this molecule is a non-polar molecule. Okay, so this is the simplified version on how you can determine the polarity of a molecule. Okay, so let's go through each of this. So, if your dipole moment is not equal to 0, okay, so first we look at the first case. Means it should have polar bond. Polar bond means you can determine the polarity of the molecule. Means there are two atoms with different electronegativity. Ini kita dah go through dah just now. Let's say you have contoh HF. Okay, so one side is partially positive, another end is partially negative, different electronegativity, right? So the dipole moment will be pointing toward fluorine and this side is positive. Okay, so next case, the shape is symmetrical but the terminal atom are different. Okay, so let's look. Means the bond dipole cannot cancel each other. When they cannot cancel each other, because they are pointed at different directions. So let's have a look at the example. Let's say you have CH3F. Okay, so the central atom, so you need to follow step by step, determine the Lewis structure, and then determine the shape. Okay, so ini kita dah belajar previously. So I will just draw the final structure with the correct shape. So C as the central atom, I'll put fluorine. Sebab fluorine is the only atom, one atom at the above. So hydrogen, I will put downwards here, pointing downwards, so that easier for you to draw the resultant later. Okay, so for this molecule, you need to determine or show the polarity. Okay, so first let's show the polarity Okay, so if let's focus on this first. Okay, it's between carbon and this hydrogen. So for this bond, the dipole moment is pointing towards carbon. Okay, kenapa? If you compare between hydrogen dan carbon, hydrogen lebih partially positive. Okay, in this case, carbon lebih partially negative. Sebab tu dipole moment, my dipole moment here is pointing toward carbon. So the same goes to these three bond. Okay, mesti tunjuk each dipole moment. Okay, so settle the bottom part of CH bond. So let's have a look at CF bond. So for CF bond, so you know that fluorine is the most electronegative atom. This will be partially negative. So carbon here will be, dia bertukar pula jadi partially positive. Just now tadi ini partially negative kan? Kejap, I'll change with different color so you can see it clearly. Okay, so untuk yang hijau ni, if we compare, partially negative, partially positive. Okay, so I'll just use a different color. Okay, so bila kita compare partially bond between carbon dan fluorine, fluorine adalah partially negative and this carbon akan jadi partially positive. Okay, so remember, electron tu dia, it can move around dalam electron cloud. So, that is why the atom, it can be partially positive. Okay, bila all the electron move away from the atom. Okay, so bila dia jadi, bila all the electron move towards the atom, okay, bila ketumpatan elektron tinggi dekat atom tu, dia akan jadi partially negative. Okay, sebab tu kita mention dia sebagai partial, separa. Okay, so the dipole moment for this will be like this. Okay, so the electron will move away from carbon and towards fluorine. So, jangan lupa buat cross di hujung yang mana yang positif itu. Okay, so biasanya kita tak tunjuk lah ni. Kita just straight away tunjuk the dipole moment. Okay, so you can see the resultant dipole semuanya menghala ke arah pointing upward. Okay, resultant is the sum of the dipole lah. So, boleh cancel off dengan anything? Tak boleh. That is why mu or dipole moment, there will be a value for this dipole moment. Therefore, CH3F is a polar molecule. Okay, so next case, what if there is polar bond and the shape is asymmetric or non-symmetrical? The bond dipole still cannot cancel each other if the shape is non-symmetry ataupun asymmetric. So dalam nota kamu, kalau kamu tak ingat apa asymmetric ni ataupun you confused, just write not symmetry or non-symmetry lah. Okay, so the example for this case biasanya melibatkan if the molecule has lone pair. Contohnya NH3. So NH3, okay, so this is the structure of NH3, correct Lewis structure with I already show the shape. So ini adalah trigonal pyramidal. So you have one lone pair here and three bonding pair. For this case, if you want to represent or show the dipole moment, okay, kat mana yang ada lone pair tu maksudnya dia adalah yang paling negatif. Okay, so hydrogen you know partially positive, partially positive, partially positive. Okay, so you can just straight away begini. Semuanya pointing ke arah nitrogen. Means electron density is banyak di nitrogen. Okay, so the resultant dipole for this case, semuanya akan sum of the all bond akan towards atas, menghala ke atas. Can it cancel with anything? No. Okay. Or you can, untuk lebih senang nampak, I always use this method. Okay. So resultant tu hasil tambahkan sum of. So ini arrow yang pertama ni. Okay, so let's have a look at the first arrow. Pointing ke atas kan, 1. Okay, so second bond, resultant dipole also pointing ke atas. Okay. So the last one, the dipole moment also pointing upwards. So the resultant dipole moment tu hasil tambah 3 ni kita akan dapat resultant dipole moment pointing upward. Okay, and you can see clearly it cannot cancel with anything. Therefore, we can deduce dipole moment is not equal to 0. Maksudnya dia ada value. Dia tak boleh cancel off. Therefore, this molecule NH3 is a polar molecule.